Hello everyone, welcome back to Informational Compass. So today we'll be continuing with the exercise 1.2 chapter 1 from question number 13. We have already solved question number 1 to question number 12 in the previous videos. If you haven't yet practiced them, you can go to the previous videos in the same playlist. So yes, let's start. So the first question is, draw the two pictures in the two planes for the equations x minus 2y equal to 0 and x plus y equal to 6. Two pictures means the row picture and the column picture. So yes, let's start with this. So this would be our first step. Let's consider the equations x minus 2y equal to 0 and x plus y equal to 6. So we'll write them down into matrix form. So writing the above equations into matrix form. The reason that I'm writing all these steps is basically to help you out in your assessments. Whenever you are assigned, you're given some assignment, so it's really required to write down all these steps. So yes, what do we have the matrix form as? X is equal to B. So how will we display this? We'll write it down as A will be 1 minus 2, right? And the second equation gives us 1 and 1. Yeah, I would request you to please solve it with me because it will help you out in practicing. So based on this, what do we get? We'll have matrix A will be A equal to 1 minus 2, 1 and 1. Now using this matrix, using matrix A, we can determine the row and the column image of equations. What we can determine? We can determine, I'll write it quickly, we can determine the row and column image of equations. So row of matrix A are the row pictures basically. Row pictures of equations. Thus, what will it be? R1 is going to be, just consider the row. So that is, I'll just mark it in this way. This is row 1, this is row 2. So how will I write? R1 is equal to 1 minus 2 and R2 is equal to 1, 1. I hope I'm clear. And similarly, and column. So now yes, you can guess this. So column of matrix A are column pictures. Column pictures of equations. Hence, what will it be? C1 is equal to 1, 1 if you consider the matrix A, and C2 will be minus 2, 1. Okay, so these are the row and the column pictures, the matrix basically formed. So now what we'll have to do, we'll have to draw the graph, right? We'll have to plot the graph. So yes, I've already drawn it for you so as to, let's save time. So this is the row picture of equations. I'll put up the snapshot of the graph formed. a minute. So this is the row picture of equations. Let's keep it this way. Similarly, I do have the column pictures too. So the column pictures of equation will be given by, if you carefully observe, this is the row picture. You just need to plot the graph. That's it. And we know how to draw, how to plot the graph, right? Consider the line equation and start drawing. That's it. And the column picture of equations is, I'll keep it this way. Yeah, so this is the column picture that we have got. So what is the result? I'll use a different pen color. Just a minute. So the result we have already drawn. This is a solution. Let me know if you have any doubt in the comment section. I'll clear it out to you again, if in case you aren't able to understand. But I hope I have explained it in a systematic way. So result, we have two results. Can you help me out? The row pictures of equations are R1 equal to 1 minus 2, R2 equal to 1, 1. Similarly, the column pictures, let's be quick. We need to wrap this exercise in this video itself. The column pictures of these equations are C1 equal to 1, 1 and C2 equal to minus 2, 1. Clear? Great. So this is our result and this is our solution for question number 13. Moving on to question number 14. Question number 14 is basically a really short one. What is the question? I'll read it out for you. For two linear equations in three unknowns x, y, z, the row picture will show 2 or 3 lines or planes in 2 or 3 dimensional space. The column picture is in 2 or 3 dimensional space. The solutions normally lie on? That's the question. So yeah. So we know that two linear equations in 3 unknowns represent 2 planes in a 3D space. That's for sure. Please remember this point. I'll write it down in as note. Two linear equations. Please remember this. This will be helpful for your competitive exams as well. Two linear equations in 3 unknowns represent 2 planes in a 3D space. Yeah. So the most common option is the one where 2 planes intersect in a line. Yeah. So the most common option is the one where 2 planes intersect in a line. In such case, what happens? Try and infer. In such case, there are infinitely many solutions, right? Because 2 equations, 3 unknowns. So there are infinitely many solutions and all of them lie on the line, on that line specifically. Okay, I hope this is clear. So what's the result? Result is the most common solution. Why am I writing result for all of these questions? Is for you to verify if in case you're solving it individually. That's the best practice I can suggest of. Practice it yourself and then check the answers from this result part. Okay, that's a good initiative that you will take for yourself. So the most common solution for two linear equations in three variables, in three unknowns basically, 1 minute, in three unknowns is a line L in which what? In which the planes, that was what a question, right? In which the planes determined by those equations. So, in which the planes intersect. Clear? I hope we are clear with this. Fine. So, we have completed question number 14 too. Okay. So, after solving 14, let's move on to 15. I'll read the question for you. The question states, for four linear equations and two unknowns x and y, the row picture shows 4 dash. The column picture is in dash dimensional space. The equations have no solution unless the vector on the right hand side is a combination of dash. So here we'll first understand these four linear equations. We'll first form these four linear equations. So yes, the solution starts for four linear equations in two unknowns, right? X and y. The row picture, we are basically trying to understand the first statement, right? So the row picture shows 4 lines. So arbitrarily such system will be given by so let's write down the equations. Give me a minute. Yeah. So yes, please solve it with me. I would encourage you to please solve it along with me so that it will save your time as well as it will enhance your confidence in solving the questions. Yes, I'll give you the system of equations if in case you're stuck. That is a1x plus b1y equal to c1. Yes, can we consider this? Yeah. Similarly for these four. Yes. c3 a4x plus b4y equal to c4. So these are our four linear equations which basically correspond to, if we write it in the matrix form, it will be a1 b1, a2 b2, a3 b3 and a4 b4 to xy equal to c1 c2 c3 c4. I hope I'm clear with this. So therefore it is easy to see that what the column picture is in 4-dimensional space. So I'll write down column picture is in 4-dimensional space. Yeah. So finally, equations have no solutions unless the vector on the right hand side is a combination of the vectors on the left hand side. Yeah, that's for sure. So finally, the equations, write it down in this way, have no solution unless the vector on the right hand side is a combination of vectors, is the combination of vectors on the left hand side. Yes. So this is the solution. So what we'll write the result as? We have got the 4-dimensional space. The equations have no solution unless, yeah, combination of left hand side. We have got all the answers, right? So I'll write down the result here itself. Where? In this question. So I'll just fill in the blanks. For 4 linear equations and 2 unknowns x and y, the row picture shows 4 lines. The column picture is in 4-dimensional space. The equations have no solution unless the vector on the right hand side is a combination of what? It's a slightly longer one. It's a combination of vectors on the left hand side. Vectors on the left hand side. Okay, so I hope I'm clear with this question number 15. Okay, so let's quickly move on to question number 16. I'll remind you, we are solving the questions from linear algebra and its applications by Gilbert Strang, 4th edition. So yes, this is used by many universities. It will help you when completing your undergraduate as well as postgraduate levels, and also help you with PhD while researching about things pertaining to linear algebra. Okay, so moving on to question number 16. I'll read the question for you. Find a point with z equal to 2 on the intersection line of the planes x plus y plus 3z equal to 6 and x minus y plus z equal to 4. Find the point with z equal to 0 and a third point halfway between. So how are we going to solve this? I'll let you know. I'll help you out. I would request you to please solve it along with me, that it will boost your confidence. Okay, so by substituting z equal to 2 into these equations, we get the following. So yes, we need to find out the intersection basically. So I'll write it down in this way. X plus y plus 3z equal to 6 intersection x minus y plus z equal to 4. This is what we need to find out, right? So please pay attention to the arrow and please pay attention to this. Z equal to 2 based on the question. Okay. Yes. So it is x plus y plus 6 equal to 6 intersection x minus y plus 2 equal to 4. Okay. Basically, we have just substituted the value of z in this. Z equal to 2. 3 2s are 6 and here 2. Right? Now let's solve it quickly. So this becomes x plus y equal to 0 intersection x minus y equal to 2. This gives us x is equal to minus y intersection x minus y equal to 2. I hope I'm clear with this. Great. Now what are we going to do? We are going to use this part here in the next intersection. So I'll write it down. Please solve it along with me. X is equal to minus y intersection minus y equal to 2. I hope you have understood this. You have substituted the value of x as minus y and you're getting the answer. So this is x is equal to minus y intersection minus 2y equal to 2. So what does this give us? This gives us x is equal to minus y intersection y equal to minus 1. Okay, great. Since y is minus 1, what will be x? X is equal to minus of minus 1 is, I'll write it down, intersection y equal to minus 1. This gives us x is equal to plus 1 intersection y is equal to minus 1. So This is our answer. When z is equal to 2, what do you get? You get x, y, z as 1, -1 and 2. Okay, moving on further by substituting. So now I'll just draw a line because we are to the next part of this question. So yes, by substituting, z equal to 0 into these equations, we get the following. What do we get? X plus y plus 3z equal to 6 intersection x minus y plus z equal to 4. So what is z? Z is equal to 0. Am I right? So now you can solve it with me. Yeah? Great. So x plus y plus 0. 3 into 0 is 0. Intersection x minus y plus 0 equal to 4. Great. So this gives us x plus y equal to 6 and intersected by x minus y equal to 4. X plus y equal to 6 intersection. We are trying to rearrange this part, x minus y. We can write it as x plus y minus x minus y. Am I right? Yeah, we can do that. So this gives us 6 minus 4 using the previous part of the intersection. Great. So this is x plus y equal to 6 intersection 2y equal to 2. Yeah. So this gives us intersection x plus y equal to 6 intersection y equal to 1. Now using this y value, so what we'll get? 6 minus 1, can I write it down? Yeah. A minute, I'll scroll a bit more down. Yeah. So this gives me x is equal to 5 intersection y equal to 1. This implies what? When z is equal to 0, you get your x, y and z equal to 5, 1, 0. I hope I'm clear with this. So finally, using these two paths, we will find the halfway. Finally, let's find the halfway point. Halfway point, let's take it as h. Between these intersection points, between these intersection points, h is equal to half 1 minus 1 2 plus 5 1 0, which is half 1 plus 5 minus 1 plus 1 2 plus 0. Yes. So this is half 6 0 2, which is basically 3 0 1. Great. So this, here we come to an end. Let us write down the result quickly, summing up all our findings. So substitute z is equal to 2 and z is equal to 0 into both equations and solve the system of equations in two variables. So it should follow the desired intersection points, which are 1 minus 1 2 and 5 1 0 respectively, that give you the halfway point. respectively. So the halfway point between, I will be providing this PDF in the form of PDF, all of these questions very soon as we complete this part, the whole basically the whole book, all these solutions. I am preparing it, and we all as a team are working really hard to provide all these solutions. So kindly subscribe to this channel, because yes, this will help us out. It will encourage us in doing a lot more. Yeah, so, and please write in the comment section if you need the solution for any of the other reference books. We'll try and we'll get started with it as well. Okay, so the halfway point between these two intersection points is 301. So this is a solution for question number 16. Moving on quickly to question number 17. So yes, I'll read the whole part for you. So the first of these equations plus the second equals the third. The first two planes meet along a line. The third plane contains that line, because if x, y, z satisfy the first two equations, then the equations have infinitely many solutions. Find the three solutions. So this is a question. Let's get started with it. I'll quickly start writing. We know the third equation is basically the sum of first two equations, right? I hope my writing is clear. Okay, fine. So therefore, if x, y, z satisfy the first two equations, then they also satisfy the third equation, right? They also satisfy the third. Yes. So now what we'll do, we'll try to find out. So let's find out the three solutions of the given system of equations. So let's find out three solutions to the given system of equations. Since the I'll just read it for you. So since the third equation is the sum of the first two, therefore automatically satisfied if the first two are right. This is what is written here. So now we are going to focus on the first two equations, because third one is automatically formed from the first two. So focus on first two equations. That's it. And how are we going to do that? We are going to find the intersection. That is what we have learned, right? So equal to 2 intersection x plus 2y plus z equal to 3. So this gives us x plus y plus z equal to 2 intersection. Please pay attention to this part. Plus z minus x plus y plus z equal to 3 minus 2. So this gives us x plus y plus z equal to 2 intersection y equal to 1. This is x plus 1 plus z equal to 2 intersection y equal to 1. So now what do we have? X plus z equal to 1 intersection y equal to 1. Again, z is equal to 1 minus x intersection y equal to 1. Moving on. Here, what do we get? X is equal to X intersection Y equal to 1 intersection Z is equal to 1 minus X. This is what we have got, right? So, this is our result. What? When X is equal to 0, X is equal to 1, X is equal to 2. Because we have kept X is equal to X. So, whatever may be the value here, 0, 1 or 2. We have three values, that is 0, 1, 1. Then the second one, when X is equal to 1, it is going to be 1, 1, 0. And for the third part, that is when X is equal to 2, we will have 2, 1, minus 1. Okay. I hope we are clear with this. Yes. So, I'll write down the result for you to refer from. So, if X, Y, and Z satisfy the first two equations, then they also satisfy the third one, right? The third. So by solving the system of equations, we get some of the solutions as by solving the system of which two? The first two, right? First two equations. We get the solutions as X, Y, Z equal to 0, 1, 1. X, Y, Z is equal to 1, 1, 0. And X, Y, Z is equal to 2, 1, minus 1. So this is a solution for question number 17. I hope you are clear with this. Any doubts? Okay. Moving on to question number 18. Move the third plane in problem number 17 to a parallel line. Okay, to a parallel plane, to a parallel plane, 2x plus 3y plus 2z equal to 9. Now the three equations have no solution. Why not? The first two planes meet along the line L, but the third plane doesn't. Dash line. So we need to find out the solution for all of them. So let's start quickly. So current equations are, okay, can start with this, right? The current equations are x plus y plus z is equal to 2. Yeah, this is equation 1. We are considering problem number 17, okay? X plus, see, these are the equations, all of these. So what shall I do? I'll take the snapshot. That would be more good. Yeah, instead of writing this whole part and, you know, a minute, I'll erase this. I'll just erase this here for our simplicity. Okay, these are the three equations based on question number 17. So this is equation 1, this is equation 2, and this is equation 3. Okay, are such that one plus 2 is equal to 3, and equations have infinitely many solutions. So moving on to the next part, that is, we will get a new system by moving. So by moving the third plane into a parallel plane that is 2x plus 3y plus 2z equal to 9. This is the fourth equation, right? Write it down in this way. The equation as fourth. We get, what do we get? We get x plus y plus z equal to 2. X plus 2y plus z is equal to 3. And 2x plus 3y plus 2z equal to how much? Equal to 9. Yeah. So this is 1, 2, and this is the fourth one. Okay. So where no x, y, z satisfy all three equations, since the third plane, that is the fourth equation, third plane does not intersect, right? That being the reason, intersect the line. You can clearly understand why, because if you're adding this, this becomes 2x, 3y plus 2z, but this doesn't become 5, which means it does not intersect the line in which planes 1 and 2 intersect. That being the reason, we have this issue that rises up. Okay, so by solving the system of equations, which equations 1, 2 and 4, we get that 0 equals to 4. Hence, no solution, right? Hence, there is no solution to that problem. So this is our result. How are we going to get the result? Just write down, it's just 1 or 2 sentences, that's it. That new plane does not intersect the line in which first and second plane intersect. Okay, so I'll just save this part. Quickly moving on to question number 19. I hope we are clear. We are solving the solution, the problem set 1.2 for question number 19. Yeah, this is a bit lengthy one. Please pay attention. It involves a lot of equations and matrices. Okay, great. So in problem number 17, we are still dealing with problem number 17. To please keep it handy. The columns are 1, 1, 2 and 1, 2, 3 and 1, 1, 2. This is a singular case because the third column is dash. Find two combinations of the columns that give B is equal to 2, 3, 5. This is only possible for B equal to 4, 6, C if the value of C is dash. So the problem, what I'll do is, for my simplicity, I'm going to again paste this solution of equations here. Okay, so this is the problem that we are dealing with. These equations represent a singular case because, why? Because columns are given by V1 equal to, you carefully observe, it is 1, 1, 2, and V2 is equal to what? Tell me. 1, 2, 3, and V3 is equal to Okay, 1, 1, 2. Very good. Where V1 and V3 are the same if you observe. Right? Okay. So without any further computations, we can easily see that columns V1 and V2 when added give, let's add V1 plus V2. What do they give? 2, 3 and 5, right? 2, 3 and 5. Now since V1 is equal to V3, we can also have that second and third column when added gives the same vector, right? This implies second and third column, that is when added gives the same vector. Yeah. So therefore, two wanted combinations are given by. Therefore, two wanted combinations are given by 1 into 1, 1, 2 plus 1 into 1, 2, 3 plus 0 into 1, 1, 2 equal to what? If you try and compute, you will get 2, 3, 5. You may verify it again. And 0 into 1, 1, 2 plus 1 into 1, 2, 3 plus 1 into 1, 1, 2 equal to 2, 3, 5. Right? So this is possible for 4, 6C when C is 10. Right? So this is possible for 4, 6C where C is 10 because, why? Because it is a multiple of 2, 3, 5 and we know that 2, 3, 5 can be shown as combination of vectors v1, v2 and v3. Yeah. So this is the solution for this question, question number 19. So I'll just write down this result here itself. So yes, this is a singular case because, yeah, because the third column is same, right? The two combinations, find the two combinations. Okay, we'll have to write down the two combinations, that is adding first and the second column or second and third column. It is only possible for B is equal to 4, 6, C when C is 10 because it is a multiple. Okay, I'll write it down all of them stepwise. Just give me 1 minute, complete that part. So this is result. Point 1 is the problem is singular because two columns are the same. Second part, two combinations are, what are the two combinations? Adding first and second column or second and third column. Okay. And the third solution is, it is possible only for 4,6C, where C is equal to 10 because it is a multiple of 2, 3, 5. Okay, so this is our result. So in this exercise, we have solved from question number 13 to question number 19. Yes, and I hope we are clear with all of them. We are going to continue in the next video from question number 20 to 23. We'll complete this exercise and start with the next one immediately. Yes, please stay tuned. Please subscribe. Please turn on the notification so that whenever the next video comes up, you are ready with your paper and pen to solve it with me. Yes, please try to promote this channel because it will encourage us, and yeah, it will help us monetize the channel really faster as comparison to growing. We want organic growth for this channel so that we all will stay motivated. And yeah, okay then, thanks a lot. Subscribe to Informational Compass. Have a good day. Bye bye.